is tricky. So let's take a look. Because lists are slow. That's our search spec. Hey, we got points! Nice! Okay, well, we just let it execute. Okay, guess this is a problem that we probably should have done better on, because it's a search. I have this starter for like searches, but whenever I see a problem, I like hesitate and wonder if it's better to just write it from scratch or to like work on the template that I have. But I think in this case, I made the right call. Quick, we'll just like look. We managed to sneak in and get 2 points. If I had noticed it, I almost missed that it stopped executing. I wonder, we will watch back in the video if we were actually done sooner and I just didn't notice because the end kind of looked funny. But anyways, part 1 is pretty straightforward. You start at the start and you end at the end, and you have to figure out basically the shortest path. The hitch is that every time you turn, you accumulate an extra 1,000 points. So you want to find the straightest possible path. In this case, obviously the shortest path kind of looks like this to the end, but this is too windy. It's better if you only have to turn once, 2, 3 times rather than 1, 2, 3, 4, 5, 6, because each turn gives you plus 1,000, and that's bad. So the way that we can model this is basically a best first search, which is looks exactly like a BFS, except we use a heap to keep track of. We want to pop the smallest possible path in length, quote unquote, off first. So we can use heap queue module to do that in Python. Other than that, it looks exactly the same. I guess some nuances are that with heap queue, the objects in our search space are a tuple, and we're going to look at the first item here to figure out what the priority of the heap is. So that's why score comes first, even though seems nicer for the position to be first. Another thing to note is that we need to know what direction we're currently facing, so that we know that if we're turning directions, we're adding like plus 1,000 to our score or whatever. So this is just typical BFS stuff, and then here's the check. If for every possible direction, I wrote this silly thing to be like, if we're north, don't bother turning south, so skip that. If the direction we're trying is the next direction, we add +1 to the score of our length. Otherwise, it implies a rotation. So we have to turn, but then the way that the search works is we go directly from here to here. So we kind of just cheat one step in the iteration and add 1001 and assume that we turn and then also step forward. And we just accumulate and return like the best path. So not too bad here. Part 2 is a little, that's annoying. Stop doing that, Vim. For part 2, basically it's count the number of spaces in any given best path. So it's not just like what the length of the best path is, because the maze is designed that there's multiple best paths. So in this case, I guess this is an easier example. There's 2 best paths. We can go here, and once we get to this point, we diverge. Both this path and this path, like the low route and the high route, are exactly the same length. So we want to return the sum, or like every tile we touch. So the naive way is a very simple modification where we also, in our state, track the path, what nodes we've previously seen, and then when we push values into a node, we just push what the current past state was plus a current node, and that becomes the new path. We had a off by 1 here, which we caught and knew that would happen because we're not actually adding the current position in when we store it in like the best paths list. This is probably slow because we're exploring a bunch of bad states that keep going further away from the solution. I think the optimal solution would also have a heuristic where if we are like further away than something good, like if we were exploring something really far away, if we like take a look at the input, if we're like the end is here but we're like way over here, we can probably early discard some bad results where there's a lot of turns, though that is a bit tricky because the turns are like plus 1000. That's kind of hard to find a heuristic for, but I don't know, we just ran the code and this is one of those cases where it happened to work out. Just refresh the page here, happened to work, we got 2 points, so can't be too upset with that solution. Go back to here and look at our times. So yeah, went from 324 to 99 on this day, got 2 points. Yeah, again, probably should have been faster here. I wonder how quickly the board locked on part 1. 10 seconds, great. 2 minutes 40. Yeah, 2 minutes 40 to code up best first search. Maybe if we started from the start it would have been faster, but oh well. Pretty happy with this overall, got some points, and be back for some more videos hopefully.